Welcome back. As I said, we're going to look at the effect of temperature on a reaction, right? Okay. So I have this reaction here from the previous case. And research, I got this information from a research data. Now, we have not quite got to thermodynamics, but you would see that this topic and the topic that's to follow, which is kinetics and thermodynamics, they're also interrelated, okay? You may have heard the word exothermic in maybe a different class, but if you've never heard of it, exothermic itself means release of heat, okay? Heat energy or heat, okay? And it's usually indicated by a negative sign. Okay, it's very important. I don't want to give any specific numerical value here because that's beyond the scope of this particular problem. All I want you to know is exothermic means heat. So on a standardized test that you might take or on my exam, I would probably say something like this. So plus heat. So when a reaction is exothermic, heat energy is actually one of the products. Think of it that way. Okay, so this is a reaction. Heat is another product, which is not written, but that's the way you have to write it, so it makes more sense. So let's say I'm going to add my tip here, okay, so that I know that it's there and not write over it. So say if I increase my temperature. Now, if you remember something, okay, temperature itself is not an energy, okay? Heat is, however, an energy, and temperature is a source of it. You can add heat, you can increase temperature by adding more heat, or you can decrease temperature by removing heat. Okay, so increasing temperature is essentially same as increasing heat. Okay, that in turn translate, if this reaction were to be exothermic, if you're increasing temperature, translate as increasing heat, which is same as adding heat. Okay, which is same as adding products, because heat is a product. Now, if you remember from our earlier case, that's why I taught that one first and then this one, because now we are adding product in this case, right? If you add product, what does that mean? That the product ratio goes up, right? So if you think about the expression, if you've added heat, your product has now gone up. What does it mean? That means the product has to come down and the reactant has to go up to reestablish equilibrium, right? Our goal is to reestablish. So what does that mean? That means we will have less NH3, right? And then we will have more N2 and H2. All right. So what does it mean for the same reaction? The reaction is exothermic, means you write the heat on the side. Say we decrease temperature. Okay. If you decrease temperature, that means we are removing heat from a system. See, there's no such thing as cold energy, okay? Cold is nothing but lack of heat, okay? So removing heat, okay, which means we're removing products because still heat is on the product side, right? If the reaction is exothermic, remove product, right? Now, if you remember from the earlier case, removing product means now we have more reactants all of a sudden, right? So if you think about this, now we have more of this, but to reestablish equilibrium, this needs to go up and this needs to go down, which means it's reestablished. Okay. So what does that mean? That means we will have more NH3, right? And less H2 and N2 when the system reestablishes equilibrium. It's very simple, okay? All you have to do is just practice a couple of times, okay? Now again, if the reaction is exo, and I believe I have done another example for endo, let's go over and finish that. So I have given a tip. If a reaction is exo, then heat is a product. Write the heat on the side. Increasing temperature means adding heat, meaning more reactants, less products. When reactants, so this is the final outcome. More reactants, less products. If you decrease temperature means you're removing heat, means the final outcome is you have more products and less reactants. So I have explained it here in more detail, but I've also summarized it through the tip here. Okay, just remember that. And again, this can only be achieved through practice. At least you practice one problem, you're going to get it. All right, let's go to when the reaction is endothermic. As I said, exo is negative, means release of heat. Endo means absorption of heat. That means the reaction absorb heat, absorption of heat. And endothermic is always indicated by a positive symbol. I'm going to put the tip here so I don't run over it, right? Now, when a reaction is endothermic, now this condition will be provided for you. Okay, you are not expected to figure that out on your own. There's no way you can figure it out with a paper and a pen unless you actually do a reaction. So in an endothermic reaction, heat is a reactant. So you write heat on this side. Now, increasing temperature means you're increasing heat, which is same as adding heat, right? Which is same as adding reactants. Now, you do not have to memorize anything. All you have to memorize is, all you have to remember is this. Whether heat goes on this side or on this side, depending on whether it's exo or endo. So if you're adding reactant, which is same as, if you add reactant, all of a sudden your denominator is higher, but we want it to be, we want it to come back to the original equilibrium value. That means this has to go up, the numerator, and denominator has to go down, which means that you're to reestablish equilibrium, right? So what does that mean? That means we have to have less N2 and O2 and more NO when equilibrium is reestablished, right? This is exactly similar to what was on the very first video, right? So what if you decrease the temperature? Well, decreased temperature means you're reducing the heat, right? Which is same as removing heat, which means same as removing reactants. All of this means the same, like it's just you have to kind of make sense of the pattern. If you remove reactant, all of a sudden your numerator is bigger because, you know, that's how math works. So we want to reduce this and increase this, the numerator, which means when equilibrium is reestablished, okay, you will have more N2 and H2 and less NO, right? And I've explained that also here in the tip picture. And this is very simple. You may all seem like, oh, it's too much to remember. Well, guess what? You do not have to remember. That's the thing. You just don't have to remember. Just try to understand from a mathematical perspective, when you add something, whether the numerator goes up or denominator goes up. And if you know that, then you know what you have to do. Okay, and I've explained that clearly in here, both graphically and through statements, right? So stay tuned for the next video on increase in pressure or decrease in pressure.